Hello. So today we are going to talk about percentiles, quartiles and boxplots. So in the beginning it may look very complex, but once you see the pattern, it will become surprisingly intuitive. So let me simplify this. What is the problem? Most beginners, they look at averages and they stop there. But in real projects, businesses constantly ask deeper questions like, who are our top customers? Which users are behaving unusually? What counts as normal? And where the risk lies? And honestly, this is where percentiles, box plots, they become incredibly powerful because they don't just summarize data, they reveal positions, they reveal spread and unusual behavior. So I'll tell you one example. Imagine a student says, I scored in the 95th percentile. What does it mean? It does not mean he has scored 95 marks. It means he has performed better than 95% of population. And suddenly, now statistics become about relative position, not just raw numbers. So let me simplify this for you. Imagine 100 runners finishing a marathon, and the average finish time tells you very little. But percentile will tell you top performers, average performers, and struggling performers. And quartiles will divide the crowd into meaningful groups. This is what analysts love. They help organize reality. So, percentile is what? It is position inside the crowd. What does percentile answer us? It answers us what percentage of values fall below this point. So, I have not run this. Okay, let me run this. This is the example of percentile data plotting. Okay, so here I have shown 90th percentile of exam scores. It can be 99 percentile of salary. It can be top 5% performers. So in real businesses, percentiles are everywhere, especially in hiring, performance analysis, system monitoring, finance. So I'll give you one insight. Percentiles turn raw numbers into relative meanings, which we have seen in the previous example. So these are the raw numbers. But you can see what is the 90th percentile. It is here. So the people who have scored about this particular uh, number are above 90th percentile. The people who have scored less than this number. So this number is definitely not 90. It must be somewhere 82, 83. So you 83.06, right? So our 90th percentile is calculated at 83 marks. So this is how you will determine. So it is relative. It is not exactly the raw number. It is relative position. So what percentiles do? They turn raw numbers into relative meaning. Okay. Then we have quartiles. So what is quartile? We are splitting reality into 4 parts, or we are dividing data into 4 parts. So what is quartile 1? It is at 25%, quartile 2 is at median, and quartile 3 is at 75%. So this helps us understand. concentration, spread and balance. Concentration, spread and balance. And most beginners don't notice this at first. Quartiles quietly describe how compressed or spread out reality is. You can see. So if you'll see the quartile visualization, you'll understand in which quartile the data is concentrated. So as I said, it will tell you what is the concentration, what is the spread, and how the data is balanced between all the four quarters. So if you have visualized the data, you'll understand maybe the data is concentrated between the two quartiles only. It will help you to understand your spread and concentration better, and will be able to do better analysis. Then we have IQR. So IQR is also known as the middle reality. So what is the full form of IQR? It is interquartile range. And what is formula of IQR? It is Q3 minus Q1. So what does it do? It measures the spread of the middle 50% of data. Okay? And why is it powerful? Because it ignores extreme noise. And in real projects, we have noise. So this is where things get tricky. Sometimes averages get distorted by extreme values. Not sometimes, mostly always averages get distorted by extreme values. But IQR will always focus on the typical behavior. After that, we have our favorite, which is outliers. So outlier detection. So what is outlier? They are unusual values. That means they are values which are far away from the normal behavior. So using our IQR, we can create lower bound and upper bound, and the values falling below lower bound and above upper bound, we can analyze them to understand whether they are really outliers or not. So this is the formula, which is a basic formula, very basic formula. Okay. So we will see outliers everywhere, and when we will understand outliers, we will understand the special cases in that particular area where it is mostly used. If you want to see any fraud transactions, if you want to see any viral post, if you want to see any abnormal medical readings, suspicious user behavior, these are the classic examples of outliers. And businesses care deeply about outliers. Okay. So outliers are often where the most interesting business stories hide. For example, if one of my video crosses million views, that will be outlier in my case. So it will tell me the story. I can go and investigate on that video why people watched it most. So it may be a topic of interest, it may be a different storytelling style, anything which might have appealed the population. So it will give me the interesting business story which will help my business to get a direction. So that's why outliers are often where the most interesting business stories hide, and we have to treat them very carefully. Okay. So see this. These values, the dots, they are outliers. This I have already explained. So after this, we will go to Boxplot. So Boxplot are also known as Analyst X-ray. Most beginners think Boxplot look boring. Oh, actually, they do look boring. But experienced analysts always love them because in that one tiny chart, a boxplot reveals median, spread, skewness, outliers, and balance. What does it reveal? Tell me. Median, spread, skewness, outliers, and balance. So when you'll see box plot, you are going to get all this information about your data. And it is basically a compressed summary of distribution behavior. So here you may see outliers, where is your median, how skewed your data is. Then you can see the spread of the data, how evenly it is spread, and balance of the data. Okay. So think like this. Outliers in finance will indicate fraud. In manufacturing, they may indicate a signal quality issue. In healthcare, if you'll have abnormal readings, you may require urgent action or maybe prompt attention to that particular area. In product analytics, extreme user behaviors, which is outlier, it will indicate power users or bots. So this is why experienced analysts, they don't just compute metrics. Their job is to investigate patterns and then understand the story which your data is trying to tell you. Now, what are the mistakes which are done by common beginners, or most of the beginners? They confuse percentile with percentage. I hope you have understood what is percentage and percentile. Percentile will give you a relative position. It is not a raw number. Okay. Now they ignore spread entirely. Spread is very important. How your data is spread. It will tell you a different story. How, if your data is not evenly spread, which is the case, then how you have to treat that particular data set. That is very important. Common mistake, and it is very big one, and I have told it in earlier videos also. They use averages alone. No, averages should not be used alone. And they miss outliers hidden inside the data. That should be a very important thing. Outliers should always be detected and analyzed and investigated. So, real world data is messy. It will always be messy. And these mistakes will become expensive if we'll do on the real world data. So, key takeaways: if you want to just remember one thing, remember this. Percentiles tell you position, quartiles reveal structure, and box plot expose hidden behavior. And hidden behavior is often where the real insight lives. So before concluding, I want to tell you, if this made things a little clearer, I would love for you to continue the journey with me. And for the resources, I will attach them in the uh, description. Okay, you can explore them yourself. Thank you very much.